Hey guys, so today we're going to be looking at the graphs of cotangent. Please turn to page 332 and you will find this picture that I have included in this video. So this is the parent function of cotangent. Notice that it's very similar to tangent. Instead of going from low to high, from left to right, it's going from high to low. And our vertical asymptotes, instead of having happening at pi over 2, they're happening at pi every time we reach pi, okay? And that's because cotangent is the reciprocal. So when we look at, this is advice for you for whatever type of function you're dealing with, whether it be sine, whether it be tangent, cotangent, always refer back to that unit circle that you love so much. Okay, so when we look at our unit circle, we know that at our pi over 2, tangent's not defined, okay? But again, we're dealing with cotangent. So being it's that the cotangent is the reciprocal, cotangent of x is the same thing as saying cosine over sine, which we could think about being x over y. All right, so when we have at 0 pi, we have the point 1, 0. Okay, so at 1, 0, when we do x over y, we get an undefined. Therefore, every time we reach pi, whether it be 0 pi here, or pi, or negative pi, whatever n pi we reach, when we divide by 0, we immediately get undefined. So right here and right here, we have our vertical asymptotes, which you can see on the diagram. Now, so therefore our period after pi, okay, our period is going to be pi. So from here to here, we are looking for values that we can use to make our graph, okay? So very similar to tangent, we have pi over 4. At pi over 4, we have square root of 2 over 2, square root of 2 over 2. So when we divide that, we're going to get 1 for cotangent. Where else will it be easy for us to find values? Definitely right here, at our 3 pi over 4. Or in general, anything over 4. Because when we divide, we're going to either result in 1 or negative 1. And here, we're going to result in negative 1 for cotangent. Okay? Now we need a third point that we can use from our period 0 to pi. What other point can we use from 0 to pi? Think about that for a second. Pause this video before I give the answer away. Well, it would definitely be pi over 2. Because at pi over 2, we have the point 0, 1. And when we divide 0 by 1, we're going to result in 0. So there are our points that we're going to use for our graph, okay? So now let's put this all together and graph it. All right, so as soon as you see cotangent function, you're going to start the same way that you do tangent. You're going to define the period, which will be pi, or pi divided by b, whatever b may be, the number in front of x, you're always going to divide by that, okay? So that's going to be your period. Your domain is going to be what x cannot equal. So what did we say before? What can x not equal? It can't equal anytime we reach our pi's, so our n pi, okay? Anytime we have n pi. Our range is always going to be all real numbers, just like it was for tangent. And our vertical asymptote, once we found our domain, we know our vertical asymptote is the same thing, except x equals. All right? So again, this is always your first step, whether you're doing tangent or cotangent. Our second step is making a table. Okay, our key points. What did we say they were? We said we had pi over 4, pi over 2, and 3 pi over 4. Okay? Those are our key points that may change depending on our b value. So when you have a number in front of your x, these will change, okay? And it's the same way that it did with tangent. So I'll do an extra example after this and show you, in case you forgot. All right, and so now pi over 4, we know that that's 1. At pi over 2, that's 0. And at 3 pi over 4, that's negative 1. So now we make that into a graph. All right. If it, let's see, let me use a different color. We'll use yellow here. And let's draw in our asymptotes. Again, and what are our asymptotes? Vertical asymptotes at n pi. So that would be at 0, right? At pi, I'll skip by 3 here. All right. And at 2 pi, I could do the negative as well, negative pi. So there are vertical asymptotes. All right, I'm going to switch back to white. And now I'm going to plot the points that we have. So pi over 4, 1. So pi over 4, let's just say, is here. So that would be 1. At pi over 2, let's say it's here. Right here. And at 3 pi over 4, we'll say negative 1 right there. And we sketch this graph. We make it look curved. I know that's not as curved as I would like it to be. Sorry. And now we just sketch the same graph. We don't need to find more points, but if you want to, you can be more exact. And we just draw a similar sketch to what we have there. Okay? And that is the graph of the parent function of cotangent. All right, now let's just add some numbers to hopefully see that it's not so bad. Oh, what is this? Okay, so let us do y equals 2 cotangent of 2x. So the first thing I'm noticing is that I do have a b. So that automatically changes my period, right? So the period is going to be pi over b, which is pi over 2. All right, now we have to find our domain. Our domain means where is x undefined, okay? Again, always use right here our period. So our period is pi over 2. So that means that our x values cannot equal n pi over 2. Okay, because before we knew from the parent that we had pi as our period and x couldn't equal n pi, but now we have pi over 2. So x cannot equal n pi over 2. All right, range. Our range is always going to be all real numbers. That's easy. And our vertical asymptote is going to be x equals n pi over 2. Okay? So now we need our key points. Okay, our key points, before we know that our key points for the parent, pi over 4, pi over 2, and 3 pi over 4. So that's kind of like your starting point. Always think of the key points. Whatever we do for the parent, now we're going to be doing for the other ones, but things just get switched around depending always on this, on your B, okay? So whatever you did for the period, that's what you have to do to the points. We have to divide these all by 2 to give us our new x values. All right, so our new x values are going to be pi over 8, pi over 4, and 3 pi over 8. Okay? All right, now, again, talking about the parent, we know that at pi over 4, that's 1, pi over 2, that's 0, and 3 pi over 4, that's negative 1. But now we have to look at the number in front. The number in front of the whole equation, and let me use a different color so we don't get confused. Right here in green, that number in front means that all of these numbers here are going to get multiplied by that number, okay? So we're going to multiply each of those by 2 to get our new table. Here, 2, 0, and negative 2. Got it? All right, now pause the video, and I would like you to plot these points, okay? There has to be a way to make straight lines, right? I'm sure there is, because Miss Carbs is not very good at that. This is a very, oh, what's this? Whoop! Just trying something new here. Let me just delete that. What is going on? Okay. I try to make it straight. Not very good, so it's gonna have to be squiggly. Sorry. Okay, so now we know our period is pi over 2, right? So let's just say here we have pi over 2, okay? So that means that we have a vertical asymptote at pi over 2. Now add another period to that. What do you get? You get pi. Okay? Now here at 0, that would be from 0 to pi over 2. That's a period. So 0 is again a vertical asymptote. And let's just do one more. Negative pi over 2. That is another vertical asymptote, right? Okay, now let's fill in our points. So pi over 8, 2. So pi over 8, we're going to just say is here. We're going to say pi over 4 is here. And 3 pi over 8 is here. All right, so we'll plot those points. Pi over 8 is 2, pi over 4 is 0, 3 pi over 8, negative 2. And we connect. And then we just sketch the rest to make it look like the first one that we drew. And we just very careful not to touch our vertical asymptotes. All right, so there you go. There is the function y equals 2 cotan of 2x. I hope that helps, and I will talk to you guys soon.